we are, beginning of week 2. This computer's already shutting down on me. We're on right there, January 12th, beginning of week 2. Then there's the 17th on Tuesday, end of week 2. 2 weeks from today is January 26th, quiz 1. 2 weeks from today is your first quiz. Man, what do we have ahead of us? Week 2, 3 parts of the assignment again. This is due a week from today. Same situation. You're now getting familiar with it. You just throw it up there on the table when you're handing your stuff. The graded stuff will be over there. As I learn your names, I'll start walking around passing it back, but it all depends if we have time. Actually, we're gonna end up getting done early because we were supposed to have a presentation today from Beta Alpha Psi. They asked if they could do a small presentation, but he backed out and wants to do it next week. So we're gonna be done 10 minutes early because I budgeted 10 minutes of time for that. Here's the 3 assignments due in a week from today. Another number line assignment, another written assignment, and another Excel assignment. Do everything the exact same way as you did in week 1. Put it all on paper so you can physically hand it in. Same with the Excel, same way. Right below here says, here's a summary, hand in the shaded bell curve. You're doing a shaded bell curve this time, with the corresponding questions answered, showing your calculations, your Excel spreadsheet answers, and your detailed calculations for the written assignment, all due before start time of class on Thursday the 19th, a week from today. Here's the materials we're covering this week, these 2 sessions, today and Tuesday. Chapter 3 PowerPoint from slide 23 to 38 this time. We started this PowerPoint in week 1, and that's on week 1 instructions, but these are separate slides for week 2. Textbook, pages 101 to 106, 109 to 113. I always, every semester, get asked about practice problems. I want to make sure everyone realizes, when you go to the instructions and go to the pages that I have on here, at the end of that section are a bunch of practice problems with the answers in the back. The answers in the back, I think, are only for the even problems, and if you want answers for the odd ones, you say, hey, I did number 3, I would like the answer to that, just email me and I will email the answer to you so you can see if you did it right or wrong. So you have tons of practice problems on top of the homework to do in the book. The only reason I'm not assigning the book problems is because when this book was brand new, I could assign book problems, but for me to do different problems every semester, I had to write my own problems. I can't keep using the book ones. So the book ones are now practice problems, and you're getting problems I wrote that are kind of like the book ones. So that's what's going on. Yeah, the lecture, I keep posting the videos. I see some people are checking them out. Are they clear enough? They're good, you can hear it, you can read it, the volume's okay? Everything's good? You don't need to move it closer, I don't need to darken it. You can even see the screen okay? Because last semester in week 2, everybody said they couldn't see the screen, so I'm trying to darken it. It's working? Everything? Okay, no one's complaining. That's all I can ask for. Let's go to something fun here, or new at least. Boom. Oh, here we go. I went kind of fast on a couple of subjects Tuesday that I want to make sure, because it wasn't part of your homework or the in-class, and that is percentiles and quartiles. I want to make sure you get these, especially that trick if the calculation does not turn out to be an integer. So let me get to it. I'm trying to remember where percentiles is. Right there. Boom. There's the trick. Is anybody willing to tell me the trick if that you do a calculation when you're trying to find percentile, and it turns out to be, we got any calculators out there? Calculators ready? For example, let's say we have the same 70 pieces of data, and I asked for the 80th percentile. Remember, that's the example we're about to see, the 80th percentile. So what would I multiply 70 pieces of data by if I were asking for the 80th percentile?
80 over 100.
0.8, that's right, 0.80, 80%. 0.8 times that, if I recall, is 56. 56. Even though, right? There's an integer. It's not 56.1, it's not 56.2. So, because that's 56, what do we have to do to find the 80th percentile? Please, loud.
You take 56 and 57 and divide it by 2.
Everybody hear that? This is only calculating the position of the 80th percentile. Now, here's the number 1 mistake. Guys, it's kind of giving away what's on your first quiz. if this is on your first quiz and it turns out you calculate 56.2 or whatever, all of a sudden someone circles it because they think that's their answer. This is not the answer. This is the position where the answer is at. You got to then look at the data and go, oh, where's the 56th or 57th number? And then that's what you're put as your answer. So don't stop when you do this calculation. You got one more step ahead of you, or two, depending if you get an integer. So like he said, because this turned out to be 56, we're going to look at the 56th position and the 57th, add them and divide by 2 to find the average. That then is our 80th percentile. Go ahead.
So when you get 56.2, do you round down?
No.
No.
Good question. She said, okay, someone help me out here. 0.81 times 70 equals 56 point something. We're now looking for the 81st percentile. 56 point what? 7? Are we rounding? Is it 7? 0.81 times 70 is
That's right.
56.7?
That's it.
Okay, there it is. But she's asking, what if it's 56.1 even? Here's the deal. Because it's not an integer now, 56.7, we don't have to go to the 56th and the 57th. We go straight to the 57th position, and there's our 81st percentile. Our 81st percentile is at the 57th position. There's no looking at any other positions. If this would have calculated to 56.1, same thing. We go to the 57th position. Now your instincts say, wait a minute, that's a 1. Wouldn't we go to the 56th position? Not on percentiles. You have to go to the next one, even if it's a 1 on here. So this would be the 57th position, just like that's the 57th position. That answer your question? How do we feel? Let's do another one. Let's do the 48th percentile. 70 pieces of data. Someone tell me what we got. I'm gonna see, 5 times 7 is 35, so this must be 34 point what?
33.6.
33.6? Well, wait on, hang on. 33.6. Is that our 48th percentile? No. We would have to go to what position to find the 48th percentile?
34.
The 34th position. You'd find the 34th position when the data's in order from smallest to largest. Now you found the 48th percentile. Okay, now we got that recalled. Quartiles. What percentile is the first quartile? Very good. 0.25. The 25th percentile is the first quartile. If we have 70 pieces of data, help me out. Let's see, a fourth of 70, 35, 17. This equals, what is this, 17.5. What position would be the 25th percentile then? I can't hear you. 18th, very good. You gotta go to the 18th, because it's 17.5. If that would have calculated to 17, you would have to go to the 17th position and the 18th position, add them together and divide by 2. If that came out to exactly 17, but it's 17.5, we're going to look at the 18th position. Now, what is the second quartile? 50, the 50th. Second quartile, so this is quartile 1. Quartile 2 is 50th percentile times 70 equals 35. Look at that. What position do we need to use to find the second quartile? Very good. She said 35 and 36, and she's absolutely right. And you would add the numbers in the 35th and 36th position together and divide by 2 because it calculated out to 35 on the nose. Now, I want to go to the third quartile, all the way here. Quartile 3 is what percentile? 75, very good. 70.75 times 70 equals, let's see, that'd be 3 of these, let's see, 17, that's 35, 35, 45, 52.5 maybe?
Yeah.
Is it really? 52.5. You guys see how easy math is? I don't know why you make it hard. Math is just easy. Come on. So there you go. We would go to what position to find the 75th percentile?
53rd.
53rd position. Let's do this now. I want to know the first quartile and the third quartile. So let's get to some data. Is this in order? It is. Ignore what you see on there except for the numbers. We want to find, we're going to start up here. you told me the third quartile is in position 53. Look at my pointer here. Hang on, where's my pointer? I can't even see it. There it is. There's 10, 20, 30, 40, 50, 51, 52, 53. What number is that? 525. There's our third quartile. I want the first quartile, which you told me is at position 17.5, which is position what? 18, very good. Here's 10, 11, 12, 13, 14, 15, 16, 17, 18. What's the number? 445. What is this right here? 445. Wait, I'm sorry, that's our first quartile, 445. Okay, our third quartile is position 53, which is 525. Our first quartile is position 18, which is 445. And watch what I'm doing here. 525 minus 445, 0. What do we have here? 4, that's 12, 11, 10, 9, 8. 80. What is the data? What does that data represent? What are we looking at? Those are what? Those are numbers that represent what? What's the story? Say it again. No, the numbers themselves. What does 425 represent? What does 570? Is that money? The rents. The rents. So what is those? Those are in what? Dollars. Remember, we were getting 70 different rents to see what the average rent would be in the area for a one-bedroom or efficiency apartment. They went all the way from $425 to $615. What we just found is $80 is what's called the interquartile range. Let me repeat. The interquartile range is when you find the third quartile and the first quartile and you subtract them, and the difference is the interquartile range. It's the inner 50% of the data, leaving off the first 25%, leaving off the end 25%, the inner 50% of the data. What an interquartile range does, it describes the data and allows what are called outliers to be out of the picture. Outliers is the data that fall way over here. Once in a while you get this data that's way up here and way down here on the number line. They're called outliers. And like 615, if that was, let's say that was 712, that's so far above 615 that it doesn't make sense. So let's say that 425 was 310. Those are called outliers. They don't make sense. They're so far away from the rest of the data. And when you use the interquartile range, all the outliers are out of the picture. Now here's the definition of range. Range is taking the largest piece of data minus the smallest piece of data, period. Everybody hear that? So what numbers would I have to find my range? What is the biggest piece of data? 615. What's the smallest piece of data?
425.
425. Let's get the difference. 0, let's see, that's a 5, it's 11, 10, 9, and 1. Dollars. The range of this data, which would be the whole range of the data, is $190, but the interquartile range is only $80. The interquartile range will always be smaller than the full range, because the interquartile range takes that full range, the outliers, the smallest piece and the largest piece of data, out of the picture, in case there's what's called outliers. All right, that was our review for that part. How do we feel? Can we calculate any percentile that we want from 70 pieces of data, for example? If I said any number from 1 to 100 as a percentile, you could tell me which one of those numbers are going to be that percentile, right? Okay. Can we calculate a range of any data after we put it in order from smallest to largest? Yeah, pretty easy, right? Can we calculate any interquartile range with enough work? That's what you need to prepare for. Because if you have a question that says, here's some data, what's the interquartile range? You gotta show work to find the 25th percentile, you gotta show work to find the 75th percentile, then you gotta show work that you're subtracting the two numbers that are in those positions, and there's your interquartile range. That's where I don't want you to fall apart, because there's a lot of work involved in just asking for that. I think you got it. It looked like it looks like your faces. So now, where are we going here? We are going to, the big part of today's lecture. Anybody follow along in slide 35 on chapter 3 PowerPoint? There it is. The infamous empirical rule. The empirical rule. The empirical rule says that when you do sampling, as long as that sample is large enough, that when you discover the mean, that usually, approximately, let me get these numbers here, from 1 standard deviation above to 1 standard deviation below, if I were to shade in underneath this bell curve, now let me refresh your memory. The area under this bell curve above this number line up into here equals 100%. Because this goes out all the way out here, but it's so small out here and so small out here that it's, I don't even draw it, right? Almost all the data usually shows up within 3 standard deviations above and below the mean when you do sampling. And right between 1 standard deviation below and above, usually 68.26. 68.26% of the data is right there within 1 standard deviation above and below the mean. It's like a standard empirical rule that it turns out this way as long as your sample sizes are big enough. And then let's go to 2 standard deviations. 2 standard deviations now, we pick up more area underneath that bell curve, and we get all the way to 95. So now I'm going to go all the way from here, all the way to here. So all of this area, if I were to put a dotted line here, and a dotted line here, and just shade all of that whole area, if the whole thing's 100%, that area there represents 95.44. 95.44% of the 100%. Or, what I'm trying to say is, once you find that mean of a sample and the standard deviation, you can say, odds are that all of these ball bearings, that 95.44% of all these ball bearings fall within whatever 2 standard deviations above 4 centimeters is and 2 standard deviations below 4 centimeters. Now, 3 standard deviations, all the way from there to there. That represents 99.72% of the area under the bell curve. Now, here's what you need to focus on. You now have enough information to use algebra to figure out what percent's underneath that bell curve for every section between every one of those standard deviations and the mean. Look at how many sections I'm talking about. From the mean to 1 standard deviation below, that's 1 section. Let me go right here. Now, one more piece of information I want to tell you. On these bell curves, the whole semester, from the center, right at the mean, to the left is 50%. From the center, right at the mean, to the right is 50%. All right, everybody see that? Now, if I said, hey, this is 50% from the center all the way into this tail way out here, that's 50%. But look, this whole thing is 68.2%. And this whole thing is right here is 95.44. But from here over is 50%, from here over is 50%. What else? Look at all the sections we have. 1, 2, 3, and then this tail, 4. 1, 2, 3, and that tail is 4. There are 8 sections to this empirical rule. If you include this little bitty area here out in the tail, by the way, that bell curve should not be touching the line. It continues right up against the line, but not touching it. So right there, there's that little bit right in the ends there. Matter of fact, 99.72 is within 3 standard deviations above and below. If we take 100% minus 99.72, we just found out how much is in the 2 little tails together. What is? Someone help me out. 99.72 taken from 100 leaves 0.28. 0.28. So how much would be in this little tail right here? Half of 0.28? 0.14%. Not even a quarter of 1%. is in that tail, and then this little tail right here is 0.14%, right? Right there. Okay, let's keep going now. Let's do some more logic. If between one standard deviation above and one standard deviation below is 68.26%, I bet you could tell me how much of the area is between the mean and one standard deviation below, just in that area, or from the mean to one standard deviation above, because they're going to be the exact same. Well, how did you get that? He said he took 68.26 and divided it in half, and that's how much is in each of those two sections. So 34.13, is that what you said? So this is 34.13%. And this is 34.13%. Okay, hang on, let's keep going now. We have to get to a point in this class to where if I said to you, what percent of that bell curve is shaded in, if I were to shade it in, and I were to shade it in from, let's say, right here, at one standard deviation below the mean to the left. If I were to shade it in from right there to the left, there's several different ways we can calculate how much of this bell curve I just shaded. The easiest way is to say, hey, I know it's 50% from the center to the left, and I know this little section right here is 34.13%, so from that line over must be 50% minus 34.13 would take me from there over. And once you know this empirical rule, I can ask you a question about any number on this number line, and you can tell me how much of the area under the bell curve there is to the left. And we are going to do this a whole bunch of times this semester using what's called a Z-chart. That's a Z-chart. This is doing exactly what we're doing, but it's doing it not just for -1, -2, -3 below the mean, +1, +2, +3, but all the numbers in between these numbers, you have the probabilities on there of how much of that bell curve would be shaded. Now, I've said to you, right here at -1, we could take 50% minus 34.13. So take 50, anybody with a calculator, 2 people at least, take 50 minus 34.13 and tell me what you get. That would be the shaded area from -1 right there to the left, the whole rest of this tail. We know it's 50% there, we're not shading this, just from there over. So 50 minus that would be what, 15.9? 15.89? 87? 15.87%, is that correct? Let me turn it into a decimal. 0.1587, does that sound correct? Okay, you ready? Now look at where we were. Right there at the -1 is what I was asking about, right? -1, -2, -3, one standard deviation below. So if I look on here at -1.0, it should tell me 0.1587. So let's take a look. So I gotta scroll down here. Here's 0.3, there's 0.3. So how you read this is, in the first column is the first digit to the left of the decimal and the first digit to the right of the decimal. Then the rows up here are the second digit to the right. So, for example, if I said, hey, what's the proportion of this bell curve shaded in at -3.5? Well, we can't do 3.5, so forget that. Hang on. How about -2.95? -2.95. Well, here's -2.9. I go across to the 5, 2.95. There's the probability. The shaded area from 2.95 to the left is 0.0016. We have 0.0014 from there to the left, so because we were at 0.295, we got a little bit above 0.14%. Matter of fact, it's 0.16%, 0.0016. But what we're asking about right now, this -1. What's the shaded area from -1 to the left? We said 50 minus 34.13 left us with 0.1587 or 15.87%. Let's see if that's true. We got to go to -1.00. There it is, -1.0, and we got to use the first column because 00. What's our answer? 0.15 right above that pointer. 87. Look at that. let's do another one. I wanna make sure you get this. You ready? I wanna go from this positive one to the left. If I were to shade where that positive one is, all the way over here, what is it I do know? What if I were to shade from the middle over, what percent's that? 50. But I wanna go from the plus one over. So 50 plus 34.13. That equals 84.13%. Let's write it as a decimal. 0.8413. So if I said to you, what's the probability from whatever that number is right there, one standard deviation above the mean to the left, you say, oh, 50% plus 34.13. Let's look it up on the Z-chart. So what number would I look up now on the Z-chart? Where am I on the number line as far as standard deviation is concerned when I'm right there? Plus 1, plus 1.00. So right there, if I want to figure that out, we know that's 50% plus 34, so we got 84.13%, but now we're going to look at the Z-chart to confirm if that's true. So we got to go to the plus Z-chart. All the way down here is the plus. There it is. We got to go plus 1.00. There it is. 1.0. There's the second zero. I'm using the first column just to the left of my pointer. What do you see? Point what?
84.13.
Look at that. Now that you see how the Z-chart works, I could ask you about any number on this number line, and you can tell me what percent of that bell curve would be shaded from that point to the left. But hang on a minute. Sometimes we have questions asking about that point to the right, not to the left. Let me say that again. We have questions that's going to say, hey, what's the probability of getting that a plus one standard deviation above the mean and to the right or greater instead of less than? Less than was 0.8413. What do you think the amount of, if this whole thing's 100%, what do you think the amount of shaded bell curve would be from there to the right? If the whole thing's 100%, what would be from there to the right? What's from there to the left? What's from right there to the left?
84.
So what would be right there to the right?
100 minus 84.
100% minus 84.13%, and the difference is 15, let's see, it'd be
87.
77? 87, thank you. 15.87. Let me write it in decimal form, that's the percent. 0.1587. This Z-chart only gives you the amount to any number on the number line to the left. You must subtract it from 100% if the question is asking about to the right. You're going to see questions that says, hey, what's the probability of this number or less? It's asking about a number on the number line or less. But then you get another question, what's the probability of this number or more? It's asking for a number on the number line to the right. You got to solve it the same way to the left, but you have that one extra step where you subtract it from 100% to find the opposite. That's the extra step you got to do when the question asks for more. Now, right now we're only using standard deviation numbers, plus 1, plus 2, plus 3, -1, -2, -3. But we're heading to where these will turn into real numbers. We got to convert them to plus 1s, plus 2, plus 3. That's where the math comes in. But right now, we're looking at just the standard deviation. So I want to do one. You ready? I want to do another one. What's the probability that we'll be at -2 standard deviations or less? So you ready? I'm asking about right here or less. So this whole area is shaded in. Now we got some work ahead of us, but can we figure out what this whole thing is from the mean to our -2? Can we figure that out? Because look at what we have here. From +2 all the way to -2 is 95.44. So to get from the mean, to get half of that area, to get these two together, we have to divide that in half. I don't have the calculator in front of me. 95 point, what is it? 37. So half of this, 47.72% is half of 95.44. So from here to here is 47.72. And we know from the middle to the end is what? 50. So if I take 50% minus 47.72%, the difference will be right there from that -2 to the left. Everything's logical once you understand the empirical rule. And this Z chart will confirm every of these. So we're gonna confirm it now. So here we go. 95.44 are both of these sections on either side, but we wanted to know from the middle over. So we had to cut it in half. So from the middle to here is 47.72. We know from the middle over is 50%. So 50% minus these two, 47.72, the difference is 12 point, oh wait, help me, 12 point what?
It should be 2.28.
2.2.
Oh, not even 12, sorry, jeez. 2.28%, right? So from there over is 2.28%, right in decimal. 0.0228, I'm coming to you, hang on. 0.0228. Let's go up here. I was asking about what's the number right here. How many standard deviations are we at? Negative 2 point, what's right on that dot? What is it? Negative 2.00. Let's go to negative 2.00 to see if our answer is correct. We're looking at -2, right there, 0, 0, right to the left of my cursor. Right to the left of it, what do you see? 0.0228. There it is. Same thing. Now,
Okay, I have a question. Okay, so
I want everybody. I want to repeat her question because I know you guys can't hear it.
so the whole thing is 100%.
The whole thing under the bell curve is 100%. Yes.
Half of that is 50.
Half of it is 50%. So to the left and to the right of that center is 50%.
And then the 34.3% is part of that 50%.
That's right. That little part from the center to that first standard deviation, that area right there is 34.13. From the center to that one standard deviation right is also 34.13. These two will be the exact same two if we calculate those two.
So the 47.72% is that part and that part together.
These two together.
Okay.
So you tell me what that is. Do you ever hear this? Hey, this is good. She said this and this together is 47.72. But I want to know what this little part is. Just this section between -1 and -2. What is that? How are you going to get it?
Just subtract 47.
Everybody hear her? 47.72% minus the 34.13 leaves this section at 13 point what? 59%. What is this one right here?
13.
That's right, same exact, they're mirrors. 13.59%. Now look at what we have, folks. We know this section is 34.13, this one's 34.13, this one's 13.59, this one's 13.59. We don't know this one yet, we don't know this one yet. This one is 0.14%, this one's 0.14%. If we take 100 and subtract this, and this, we'll know what these two are. Once you know all 8 sections, I can ask you any question and you can estimate it out just by looking at that. You can just estimate it. Now wait, are you ready? Now I'm putting this all together. I may be going too far. I don't want to lose anyone. So so tell me if I lost you, but let's go to the homework we just did. Let's go to the easy one. Hang on, let me go to the easy one. There's our homework. Now, I'm going to work on this now. Here we go. Let me get a different color. No, here we go. What are the numbers? 118, so I'm going to put 118 here.
130.
Let's go up. 118 plus 12, so that's 130. 142, is that right? And 154? 154. Give me the numbers here. 118.
106.
106.
94.
What is it?
94.
94.
82.
82. Okay. Now you're getting ready for statistics. The question's not going to be, what's the probability that we'll be at -2 or less, or that the +2 or less, or anything like that. Now you're going to be asked the numbers. Once you have the numbers on the number line, everything's the exact same. You ready? What's the probability that our data, we randomly select something out of the data, we know our standard deviation is 12, we know our mean is 118, and that one we pulled out of there is 106 or less. I just asked you the same question as what's the probability to be at -1 or less, right? Let me show you how I know it's -1, because it's landed right there, but here's the math. You take what you're being asked about, minus the mean, and you divide it by standard deviation. And if I did this right, that should equal -1, because 106 is right there at the -1. 106 is right there at the -1. That is how you convert every one of these questions to the standard deviation numbers that are on that number line, and your result will be between +3 and -3. And then you go to the z-chart to answer the question. I'm asking right now, what's the probability that we just picked out a random item out of this bucket, and it's 106 or less? When the mean is 118, the standard deviation is 12, what's the probability it's going to be 106 or less? Here we go. We can look up -1 on the z-chart, or look at the math. 50% minus 34.13% would be right there. We know it's not 50%, we know we can take that off of there, so the difference, we did it already, hang on, where's 50%? We did this already. Here it is. No, that's not it either. Where's 50% minus 34? What is it from -1 over? What is it? What is it? This is it right here?
Yeah.
Okay, this is it right here. There it is, we did it already. But now you're looking at a legitimate question. There's a whole bunch of questions in your future that are exactly what we just did. Let me do another one. The mean is 118, the standard deviation is 12. What's the probability that you're going to pick one out of the hat and it's 130 or less? 130 or less. I'm really asking about what number on the standard deviation?
1.
A +1. So you would just look up +1, or if you know the empirical rule, you'll take 50% plus 34% at 0.13, which we did already.
Is at the top.
Is this it?
Yeah.
There's our answer. But the story goes like this. You ready? Some blah 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 data has 118 liters with a standard deviation of 12 liters. Show your calculations to determine what the probability is that we pulled one out of the batch and it's 130 liters or less. You ready? 130 is being asked about. The mean is 118. The standard deviation is 12. It should turn out to be +1 if I did it right, because I'm asking about 130, which is right at the +1, correct? Now I look up +1 on the z-chart, or I know the empirical rule. 50% is there, add another 34% to it, 84.13%. Or point. You can, by the way, your answers can be in decimal or percentage. It's up to you. If you put it in percentage, add the percent symbol though. So you could say 0.8413, I'll take it. Or you can say 84.13%, I'll take it. They're both the correct answer. Go.
Okay, so.
Oh, sorry. Yeah, I thought you. Go ahead. No, go ahead. Keep going. I'll go with him next.
Okay, I was gonna say, there's so many different ways to calculate the answer. Say we got it from the z-chart, would we just write got from the z-chart?
Yep, the instructions will say if you use the z-chart, tell me if you use the positive or the negative z-chart. Just tell me which one you used. And then you say, and you just give the answer off the z-chart then. You say, I use positive z-chart, here's the answer, 0.8413. Go ahead.
We deal with numbers that were past 4 digits. Would you want us to cut off or round?
Say that one more time. If we use numbers that are past what?
5 decimal points over.
Oh yeah. You can use it just as you got it on your calculator, or if you're gonna round it, leave at least 4 digits to the right.
I got you, but do you want us to cut it off or do you want us to write the full number?
The full number, or cut it off by rounding. It's up to you.
Okay.
As long as you leave 4 digits to the right.
I got you.
But if you notice, if you're using the z-chart, all of them are 4 digits to the right. Let me show you here. They're all 4 digits to the right, but if you turn it into a percentage, you're only leaving 2 digits to the right. But because you said you used the z-chart, that's all I expect. So you'd only have 2 digits to the right decimal, or 4 digits if you leave it in decimal form. If turning a decimal into a percentage is a big deal for you, leave it in decimal form then, because I accept this as an answer, whatever you got off the chart. Okay, now we're gonna try a hard one. I've never taken week 2 this far, because we have this little bit of time here. Are you ready? This isn't gonna be at -1 or +1 or +2 or -2. I'm gonna give you a number in between the numbers. Are you ready? Here we go. 118 is our mean, or standard deviation is 12. What's the probability we just picked one out of the bunch and it's gonna be, hang on, 110 or less. 110 or less. 110, I don't know what this is, liters, I think. 110 or less. Now look, I didn't ask you about 106, I didn't ask you about 118, but I bet you can kind of estimate what the answer is here, because you know at 106, what was that? That one was like 15, whatever 50 minus that is, 15.87. And you know at 118 it's 50. So I'm asking you about something that's between 50 and 16%. Somewhere in there is the answer to this question, right? And as you notice, the closer we get to the mean, the more bell curve there is in that percentage. But I think 10 is 6 above here and 8 below there, so it's almost the middle. Almost the middle.
Can you scroll down?
66.67%?
You think so? No, it's gotta be less than 50, because I'm asking about 110 or less. So it's gotta be less than 50, but more than whatever this one was, 15.7.
Can you scroll-
44.
So can you scroll down just a little?
Hang on. Okay, hang on. But what are you gonna look for? What number are you looking for? What? How do you know what number to look for?
-0.6.
What is it? Say it again.
-0.666.
Here's what's going on. This is what she was saying too. They're calculating what the z would be from that formula I just showed you. If this is -1 and that's 0, they're trying to figure out what that number would be right there. So what they each did is they said, oh, you're asking about 110. So 110 minus the mean of 118 divided by the standard deviation of 12 equals, and you got 0.66.
Negative 2/3.
Oh, I'm sorry, -0.66. What was the next digit?
6, 7.
Repeating?
Yeah.
Okay, so I'm taking it out 4 digits. There it is. I took it out 4 digits. 6. There is the number we gotta find off the z-chart.
Oh,
That is right there. That 110 is sitting on the number line at standard deviation of -0.6667. So here we go. The z-chart though only goes 2 digits to the right. So what do I need to look up on the z-chart? Only 2 digits to the right we can go here. -0.67. Here we go, -0.67. He said scroll down a little because there's the -0.6. The next digit after that's what?
7.
So I gotta go all the way over to the 7. Hang on. Where's the 7? There it is. Just to the left of my pointer. Where am I? Right here. Point, help me out. Point 2514. The right there, that makes sense because it was, look, it was almost 16% at the -1. It was 50% at the 118. So the 110 over is at 25%, just a little above 25%. Wow, you guys, we're way ahead of schedule now. This class is too easy. That's all I got for today. We're gonna pick up from here on Tuesday. Well, I'm gonna prepare you for the homework on Tuesday. It's posted if you wanna look at it, but I'm preparing you for it on Tuesday.